Hello, welcome to your lesson on half-life graphs. What you need to do first is answer the do now questions. Pause the video, answer the questions in your notebook, and then come back when you've answered them. Okay. So to find half-life, half-life is the time for activity to reduce or to half, to half, and that's half its initial value, okay? Okay, what is an alpha particle? It is a helium nucleus that's emitted from an unstable atom. What is the charge on a beta particle? Well, a beta particle is an electron, so its charge is -1. Okay, what happens to the mass of an atom when it emits a beta particle? Well, an electron has pretty much no mass, so its mass will stay the same. Okay, and what happens to the atomic number of an atom when it emits a beta particle? Okay, so the atomic number is going to increase by 1. Okay, so make sure you got those in your notebook. Okay, and as I said, we're looking at graphing today. Okay, in your science exams, graphing is massively important. Okay, you can see down here that just for plotting the graph, you get 2 points. You lose 1 point for each incorrect plot. Okay, so you only get half a small square as an error, and a reasonable curve through the points. Okay, so if we look at our graph today, we've not got a straight line, we've got a curve of best fit. Okay, you're going to have to use the drawing tool to try and draw that. Obviously, we're mostly looking at the plotting of points today. Okay, so we'll look at what we need to do. So today, you are going to be using the graphs to find the half-life, okay, to start off with. Alright, so let's look at what we need to do. Half-life is the time for the activity mass or number of parent atoms to decrease by half, okay, so that's over here. Okay, number of parent atoms left. Okay, how do we find the half-life? Well, we find the initial value where time equals 0. So time is 0 here, the initial value is this value here. Okay, so 16. So let's draw a little circle around 16. Okay. So we've done that. Okay, find half the initial value. So 16 divided by 2 equals 8. Okay, so there's our, let's draw a box around that. Find the half the value, okay. Draw a horizontal line from the y-axis to the curve. So I'm going to use a ruler to draw a horizontal line. Oh, not in the right place though. Okay, to the curve, and it meets the curve there, so I've done that. Okay, next bit, draw a vertical line from the curve to the x-axis. Okay, so what is the half-life? Well, in this case, it's number of half-lives, and that is 1. Okay, so make sure you've got that drawn in your notebook. Okay. And we're going to do the same thing again here. All right, so find the initial value where the time equals 0. Okay, so time is 0 is here. There's our initial value of 80, okay, half of that, so a half times 80, okay, so I've done it a different way there, half times 8 equals 40, okay, so let's draw a little box around this. There's my value for half. Draw a horizontal line from the y-axis to the curve, so I've put my ruler down, drawing my line, there we go, okay, I've met the curve. Now I need to draw my line down from where that line meets the curve. Okay. Alright, you should be able to do this much better. Okay. On the notebook, so half-life equals 2, and we're going to put days. Okay, because just here we've got our units. Okay, so that's 2 days. For a half-life, okay? If we were to half that again from 40 to 20 and we draw our line across, okay, it goes to 4, and you may be thinking, hang on, the half-life has changed, but from 4 to 2, or from 2 to 4, is still 2 days, okay? So if we draw a line across again, it goes to 6, and we go from 4 to 6 is 2 days, okay? So the half-life is always the same. Okay, so we've got some progress review questions now. So the graph is going to be the same for all 3 questions. So the first one is, what is the count rate after 100 days? Okay, what is the half-life for this radioactive substance? We've just found out how to find the half-life. And how many half-lives would it take for the count rate to fall from 200 to 50? So a bit of a check back to our learning from last lesson. Okay, so answer those questions. You can pause the video, answer the questions, and then we'll go through the answers in just, well, when you unpause the video. Okay, so what is the count rate after 100 days? So the first thing we need to do is we find 100 days. Okay, so it says time in days here, so 100 days. Okay, so the reverse of what we've just done, we're going to draw a line up, meet the curve, we're going to draw a line across. Okay, so it is 400. Okay. Next one, what is the half-life for this radioactive substance? So let's work through our checklist again. Our initial value is 800. Half of 800 is 400. So we're going to draw our horizontal line, meet the curve, and then drop down. There we go. Our half-life is 100 days. Okay. Oh. There we go. How many half-lives would it take for the count rate to fall from 400 to 100 counts per minute? Okay, so 400 is here. Okay, I know that half of that is 200. Okay, half of 200 is 100. Okay, so if we go 400, 200, 100. Okay, that's 0 half-lives, 1 half-life, 2 half-lives. Okay. So the answer is 2 half-lives. Right. There's 3 problems now for you to complete on your own. Okay, so I've left the success criteria for you here, so you know what to do. Find the initial value, find half that initial value, okay, and then you find the time. So you're going to have to work out what each box is worth here. Okay, so if 10 boxes are worth 4, 1 box is worth 0.4. Okay. Next problem, exactly the same thing again. Okay. Initial value, half the value, find the half-life, and finally, same thing again. Use the success criteria, work through it, and you'll be able to write in the half-life. Okay? Right, so you'll need to pause the video to go answer those questions, then you can come back and carry on with the next part of the video, okay? So, here we're talking about graphing successfully, okay? So let's look at this. We're not going to write feedback, but let's think about what's wrong with this graph, okay? So, first up, let's look at these axes, okay? Because we've got scale axes, labels, titles, units, okay, and equipment, okay. First off, it's drawn in pen, okay, so we need to draw in pencil when we're working on paper. Secondly, let's look at the scale, okay, so we go from 0 to 1 here, this small gap, and then we've got a big gap from 1 to 2, okay, and then all the gaps are the same size. So this needs to be much bigger, okay, so let's put a red circle around that. There's an error there, okay? So our scale is incorrect. We've got our axes around the right way because we've got count rate here. We haven't got a title here though, or a label, sorry. Okay, that needs to be labelled. Label our axes. We need units. We've got units up here, but we haven't got units down here. Okay, and this line of best fit doesn't really go through our data very well at all, does it? Okay, we could have made this, used much more of the graph paper and made a much bigger graph, okay, using at least half the piece of paper. Right, okay, we'll go through graphing again when we see you in class, because we can't give you graph paper when you're at home. So what we're going to do today, I am going to show you how to draw this graph, okay? So I'm going to look at this set of results, okay? It looks a bit scary, and that's why I'm doing this set of results. I'm going to focus on the class set of results, okay? And I'm going to show you exactly how to plot your points and draw a curve, okay? So this is what a good graph should look like. You can see that all the gaps are the same size, worth the same value. We've got units down in this bottom corner as well as a label. We've got a title here, okay? Really clearly labelled, nice, clear plus points. To indicate where our points are, okay? Alright, so let's have a look at this graph, okay? So, it's already labelled. We don't have any units for this, okay? Because it's a number here and a number here, so they don't have units, okay? So, let's plot our points, okay? So, my first point at 0 is 400, okay? So I find 0, and I go up to 400. Okay, so I'm going to use a blue pen here. I'm going to make a plus. Okay, there's my first point, so I tick that one off. Next point is 1 and 330. So I can see, because we've got 5 little squares in between 300 and 350, every single little square is worth 10. So it goes 50, 60, 70, 80, 90, 100. Okay, so up here, across to 1 on the number of rolls. Okay, 300, 310, 320, 330. Okay. Let's draw a little cross for 330. Okay. Number 2 is 280. We go 230, so we find 200 and go up 3. Okay. Remember, if you make a mistake, just rub it out. That's why we work in pencil. Number 4 is 190. Number 5 is 160. Number 7 is 110. No, sorry, we need to do number 6 first, don't we? This is why we should tick them off. Number 6 is 130. Okay, number 7 is 110. And then finally we've got 8 on 90. Okay, so I've plotted my points. That's what I'm looking for you to do today, plot your points. Okay, and I'm just going to try and draw a single curved line that goes through all of my points. Okay, now that's not very good. It's very difficult to draw a curve using the pen that I've got. I think that's the best I'm going to get, I'm afraid, because of the pen I'm using. Okay, so try your best to draw a smooth curve. I can see that your plotting would be pretty good. I'd give you marks for that plotting. The curve, we're going to be able to draw it much better with a piece of paper and a pencil. Okay, so there's the eye finish off this question. Okay, and it should say, well, it does say, find the half-life. Okay, so the half-life equals, okay, so we've got an initial value of 400, so when it drops to 200 we find the time. Okay, it's going to be around about here. Let's use our ruler so we do it properly. That was terrible. Okay, meet the line and then drop down. Okay, and I can see it's around about 3.9. Okay, on your graph it might be slightly different because of the errors in my curve. Okay, 3.9 rolls. Okay, all right, so all right, here's the we do. Okay, again, looking at the time is across the bottom. Okay, 6,000, where's that going to be? Well, it's dead in between 4 and 8,000, isn't it? Yeah, 12,000 there, 18,000 is going to be dead in the middle, 24,000 there. Okay, and then we've just plot these points using that. Okay, all right, so I'd like you to try and plot that graph. And we just need, for these 3 graphs, plot the points, or these 2 graphs, sorry, plot the points. Okay, and the final graph you're plotting is this one. Okay, so these are all GCSE questions, but I know that you're going to be able to answer these really, really well. Okay, and then work out the half-life for each one. Okay, right, good luck with your learning. If you have any questions, please pop them in the chat underneath the assignment so your teacher can then look at your work whilst you're working. All right, submit your work before the end of the lesson. Good luck. Thank you very much for watching.